Welcome back to Object-Oriented Programming with C++ here at database-tutorials.com. Here in this video, we're going to be taking a look at casts. In our last video, we looked at a lot of different things as far as automatic conversions go and unassigned data types, as well as cascading the insertion operator. We also looked at the setW manipulator. So in this video, we're going to pick up where we left off at, and we're going to continue on with casts. Now, caste sounds like something to do with social classes in India, but in C++, the term applies to data conversions specified by the program, as opposed to the automatic data conversions we just described. Casts are also called typecasts. And what are casts for? Sometimes a programmer needs to convert a value from one type to another in a situation where the compiler will not do it automatically or without complaining. There are several kinds of casts in standard C++: static casts, dynamic casts, and reinterpret casts, and constant casts. Here we'll be concerned only with static casts, and we'll learn about the others, which are used in more specialized situations in later chapters. C++ casts have a rather forbidding appearance. Here's a statement that uses a C++ cast to change a variable type int into a variable type character. Here, the variable type cast, an integer variable, is placed in parentheses, and the type it's to be changed to character is placed in angle brackets. The result is that an integer variable is changed to type character before it's assigned to a character variable. In this case, the assignment statement would have carried out the cast itself, but there are situations where the cast is essential. Recall that in the Citus example, an intermediate result exceeded the capacity of the variable type, resulting in an erroneous result. We fixed the program by using unassigned int instead of int. This worked because the intermediate result, 3 billion, would fit in the range of the unassigned variable. But suppose an intermediate result won't fit the unassigned type either. In such a case, we might be able to solve the problem by using a cast. So here's an example. So I'm just going to start by clearing my main here, and at the top we're going to change our comment. The last one was for shows mixed expressions. This one's going to be for tests and sign and unsigned integers. And then this is going to be a cast.cpp, and we're going to keep our same return 0, but we're going to clear out our main, and then we're going to initiate another variable called int variable. We're going to set that equal to 1.5 billion. All right, this is going to be, let's just make sure we have the right amount of zeros here. 1, 2, 3, 1, 2, 3, and we don't. We're missing one more 0. All right, and then I'll do int variable. I'll set that equal to int variable times 10 divided by 10. So what this is doing here is this is taking int variable that's already 1.5 billion and setting it equal to 1.5 billion times 10 divided by 10. And then I'm going to do a cout, and then I'm going to say int variable is equal to, and then I'm going to print it out on the screen, int variable, and then we're going to do an end line, and then this is going to be displaying the wrong answer, and it's going to show us that our result is too large. And then I'm going to say int variable equals, I'm going to set it right back to 1 billion. It's going to be int variable equals, and then this is going to be cast to a double. We're going to be casting this to a double, so I'm going to say int variable static underscore cast double. This is our cast right here, and then int variable, and then that's going to be multiplied by 10, and then that's going to be divided by 10, and that should be equal sign int variable equals static cast under, which is to be a double, int variable times 10 divided by 10. So that's casting the int variable to a double here. and then we're going to see out, and then we're going to say int variable is equal to, and we're going to print it out on the screen, and then we're going to end line, and then this is going to be the right answer. Right? Need to end line here, and that should fix our syntax errors. And so if we build and run this, it should pull up our CPP here. You see at the top, int variable equals out of range automatically for 1.5 billion. We need an unsigned int or a double. And so now if we look at our second one, int variable 1.5 billion, this one is the right answer because we casted it to a double, and then we did it times 10 divided by 10, and that's what got us our answer when we printed it out on the screen the second time. So casting it to a double is what brought it in range for us to be able to successfully use our mathematical expression. So I'll press any key to continue, and I'll close that out. And so when we multiply the variable int variable by 10, the result 15 billion is far too large to fit in a variable of type int or unassigned int. This leads to the wrong answer as shown by the output of the first part of the program. We could redefine the data type of the variable to be double. This provides plenty of room since this type holds numbers with up to 15 digits. But suppose that for some reason, such as keeping the program small, we don't want to change the variables to type double. In this case, there's another solution. We can cast int var to type double before multiplying it. This is sometimes called coercion. The data is coerced into becoming another type. The expression static cast double int variable cast int variable to the type double. That's what this is doing here. Static underscore cast double int variable, cast it, the int variable in parentheses here to the type double that we have here. It generates a temporary variable of type double with the same value as integer. Int variable, I mean. If it is this temporary variable that is multiplied by 10, since it is type double, the result fits. This result is then divided by 10 and assigned to the normal int variable. Here's the program's output, as we just seen. The best answer without the cast is wrong, but in the second answer, the cast produces the correct result. Before standard C++ casts were handled using quite a different format. Instead of a character variable equals static cast character and int variable, you could say a character variable equals character and int variable, or alternatively, a character variable equals character int variable. So in other words, what he's saying that we could do is we could say a character variable equals, we could just put double, and then we could say int variable. And then that would initialize, that would cast it over to a double there. Oops, that's not the right. Gotta make sure that's right. And there you go. That would cast it over to a double there. Or we could do int variable equals double int variable, and that would also do the cast for us. And then what we just did was int variable equals, and then we said static cast, and then we said double, and then in parentheses we did int variable, and that's what did the cast as well. One problem with these approaches is that they are hard to see. The syntax blends into the rest of the listing. They are also hard to search for using a find operation with your source code editor. The new format solves this problem. Static underscore cast is easy to see and easy to search for. These alt casts still work, but their use is discouraged or deprecated, to use the technical term. Deprecated means basically it's no longer in use, and it's in some PC terms obsolete. In programming, that could mean the same thing. Cache should be used only when absolutely necessary. They are a controlled way of evading type safety, which means making sure that variables don't change type by mistake, and can lead to trouble because they make it impossible for the compiler to spot potential problems. However, sometimes casts can't be avoided. We'll see some examples of situations where casts are necessary as we go along. So before we get into arithmetic operators, we're going to go ahead and we're going to end video here. So arithmetic operators will be talked about in our next video. In this video, we talked about casts and different ways that we could convert a variable over to a different data type. And in this video, we looked at how to convert an integer to a double in order to achieve the correct answer based on our arithmetic expression that we were attempting to do. So I'll just go ahead and clean this up a bit so this looks a little bit more the way it should look. So thank you for watching. If you're interested in our next video, you know what to do. Head on over to database-tutorials.com or check out our YouTube channel here, Database-Tutorials. And yeah, until next time.